Hello everyone, we're going to talk about classifying polygons in this video. In my next video, we will cover angles and polygons, which refers to interior and exterior angles and polygons. So the objective for this video is describe polygons. And here we have our first classification, which is convex or concave. That means we can take a polygon and we can classify it as one of these two. What is convex? What is concave? I'm going to show you. When we take the sides of a polygon and we extend those sides like so, when we extend in both directions, now we're going to take this side and I extend in both directions. Notice when I extend this side, look at what happens. Part of the extension comes inside of the polygon. When that happens, we say that the polygon is concave. See, when I extend this other side, it also comes inside of the polygon. So we call this concave, okay? This is when we extend all the sides. Notice how a lot of the sides will extend towards the inside of the polygon. There you have it, okay? So that's what we mean by concave. This is concave. When I extend my sides, they come into the inside of the polygon. Convex is the contrary. When I extend the sides of a polygon, none of these extensions will be in the interior of the polygon. You see, all of these extensions of the sides, none of them fall inside the polygon. And there you have a nice star. Okay, so this is convex. Two classifications you can use when you're classifying polygons. Let's see, the side of the figure is convex or concave. For number 1 here, we have that I know this is convex. How do I know? Because when I extend these sides, I can visually see that none of these side extensions will fall inside the polygon. So that's how I know it's convex. You don't have to draw the extensions if you don't need to, but if you do, go ahead and do it. Okay, so when none of these extensions fall inside of the polygon, that means it's convex. Now here, I wanted to, on our last slide over here, let's go back to the last slide. When we have concave, we know that it's concave when we have these dents in our polygon. I don't know if you notice, it's like if we pinched the polygon and formed these dents. Anytime you have dents like that, you're going to have extension lines falling inside of the polygon, and that's going to make it concave. So for this star here, I have many dents. I have a dent here. I have another dent. All of these dents, when I extend, for example, if I extend this side of the star, if I extend it, notice how one side of the extension will be inside here too. When I extend these dents, they all fall inside of the polygon. So, okay? That's why this is concave. I hope this is clear. I can also classify a polygon by equilateral or equiangular. Equi means equal, lateral means sides. So equilateral, equal sides. Whenever a polygon has all sides congruent, we say it's equilateral. Whenever a polygon has all angles congruent, we say it's equiangular. And whenever a polygon has both, all sides congruent and all angles congruent, we say it's a regular polygon. So in this first example, notice how all sides are congruent. All my angles are right angles, so they are all congruent, right? All right angles are congruent. So this is a regular polygon. This is regular. If I were to classify it, for example, let's say this is a convex, right? It's convex. It's a quadrilateral. It's a convex regular quadrilateral. I have another name for this, which is the square. If you say square, we know it's convex. We know all sides are equal, and we know all angles are equal. So either of these two names are correct for this polygon. For this polygon here, all sides are congruent, all angles are congruent, therefore it is a regular polygon. We also know this as an equilateral triangle. And by the Isosceles triangle theorem, we know that if two sides are congruent, then their opposite angles are also congruent. So this makes all three angles congruent. So this is an equilateral triangle. I can also say it's a convex, regular triangle. That would be another name I could name this figure. This one here, this is a hexagon. It has 6 sides. All sides are congruent. All angles are congruent. Therefore, this is a regular polygon. But we can be more specific. We can say it's a regular hexagon, right? We can say it's a regular convex hexagon. Okay? Determine if these polygons are regular or not. Let's see this first one, letter A. First thing we notice is the sides. Are the sides congruent? Nope. This side is not congruent to this side. So since this side is not congruent to this side, this is not equilateral. If it's not equilateral, it can't be a regular polygon. So it's not regular. Now, even though it doesn't ask for this classification, we're going to classify it just for practice. So this is an octagon. It has 8 sides. Even though it's not a regular polygon, I can still say that this is a convex, equiangular, because all angles are congruent. I could say it's a convex, equiangular octagon because it has 8 sides. Okay? How about this one? Is this one regular? Your answer should be yes. It's regular because all sides are congruent, all angles are congruent, so it is a regular polygon. Let's classify it. It is a convex, regular pentagon because it has 5 sides. Okay? When we say polygon, poly means many. It means many sides. When we say pentagon, we're being specific about the amount of sides. Okay? So convex regular pentagon is the way we would classify this polygon. And this polygon here, I can't say it is regular. It is not. Why not? Because they don't give us information about the angles. And in order to say it is regular, I need to know if the angles are congruent. So all I know about this figure, the way it stands, is that it has all congruent sides. That means that this is equilateral. And it is concave. I can say this is a concave equilateral. And let's see how many sides. 1, 2, 3, 4, 5, 6, 7 sides. That's a heptagon. So this is a concave equilateral heptagon. Decide whether the polygon is convex or concave. Convex or concave, okay? And then decide if it's a regular polygon, okay? Let's do number 1. Is it convex or concave? If you need to, you can go ahead and extend all the sides. And when you do that with this polygon, you'll notice that none of the extensions fall inside of the polygon. That tells you this is convex. Is it regular? That's our second question. Well, in order for this to be a regular polygon, I need to have all angles congruent with each other, and that's where this fails. This angle here is not congruent with this one. So therefore, this is not a regular polygon. Okay? But if I wanted to classify this, I could go ahead and do that even though it doesn't ask you to. We're going to do it just for practice. This is a 4-sided polygon. It's a quadrilateral. all sides are congruent, okay, I can say this is a convex equiangular, equilateral, because the sides are congruent, equilateral quadrilateral. I can also call this a rhombus. Because notice, all sides are congruent, and that is the definition of a rhombus. All sides are congruent. Also, opposite angles are congruent, and that's what we see here. So I can probably call this a rhombus, okay? Because this is going to make opposite sides parallel when the opposite angles are congruent and all sides are equal, okay? For number 2 here, I have all sides are equal. First of all, is it convex or concave? Before I skip to that part, let's see if it's convex or concave. Well, notice I have a dent. That tells me this is concave. Okay? Concave. And is it regular? Not regular. Why not? Because I don't have any information on the angles. I don't know if they're congruent. Okay? So I can't say it's regular. I can say that this is a concave equilateral, and let's see how many sides. 1, 2, 3, 4, 5. Pentagon. I can classify it like this. Okay, for our last one here, is it concave or convex? It is convex. And is it regular? Yes, it is regular. It is a regular polygon. And you've answered what they wanted, but let's go ahead and classify it. This is basically a convex, regular, quadrilateral. Okay, and we can also call this a square. Okay. Here we have an exercise. It says that the polygons are equilateral. That means all sides are equal. Find the perimeter. What is perimeter? Perimeter is the sum of all sides. Okay, so if this side is 5 inches from here to here, and I know it's equilateral, that means it's 5 inches from here to here, and from here to here it's 5, and so on. So each side is 5 inches. And since the perimeter is the sum of all sides, I can say that perimeter is equal to 5 plus 5 plus 5 plus 5 plus 5, which is the same thing as saying 5 times 5, which is 25 inches. That's my perimeter. For this one here, this is an octagon, right? 8 sides, and it's equilateral. So all the sides measure 2 inches. So when I look for perimeter, since all the sides are 2 inches, all the sides are 2 inches, and I have 8 sides, that gives you 16 inches. And for our last example here, it says that the polygons are regular. Now remember, regular means all angles are congruent and also all sides are congruent. So for this triangle here, I know this side is congruent to that side, congruent to that side, and I know that this angle is 60, this one is 60, and this one is also 60. Okay? So if this angle here is 60, I can write a statement that says that 2x plus 10 is equal to 60. And now I can solve for x. We want to isolate this term. That means leave this term alone on this side of the equal sign. And we do that by subtracting 10 on each side. You'll get 2x on this side of the equal sign, and on this side you'll get 50. That leaves you, when you want to solve for x, you divide by 2, and that tells you that x is equal to 25, because 50 divided by 2 is 25. Okay? In the second example, I have the sides. If it's regular, I know all sides are congruent. Okay? and all angles are congruent. So if this side measures 70, that means this measures 70, this measures 70, and also this side measures 70. So I can write my statement equal to 70. Isolate this term by taking away that 10 that's beside it. You do that by subtracting 10 on each side, and you get 3x is equal to 60. And we divide 3x by 3 to isolate the x on each side. X equals 20. Okay, in both cases, if I go back and substitute the x that I found, if I substitute x equal 25 into here, I'm going to get 2 times 25, 50, plus 10, 60. So that checks out. Always go back and check your answers and make sure you didn't make a mistake. If you didn't get 60, something's wrong. And for this one, go back and plug this in. Okay, so if x is 20, that means 3 times 20 is 60 plus 10, 70. If you get something different, then your x, the x that you found, has some kind of mistake here. Okay, I hope you've enjoyed this video, and I will see you in my next video where we're going to talk about interior and exterior angles in polygons. I'll see you then.